So in the previous lecture, we were discussing types of the solutions of a differential equations. We discussed types of solutions of ODEs and n parameter family of solutions. We discussed n parameter family of solutions of the ODEs. Today we are going to discuss solution of first order. Today we are going to discuss solutions of first order ODEs. Okay. And then initial value problems. So previously we haven't discussed how to solve differential equations. Today we are going to discuss how to solve first order differential equations. In the previous lecture, I told you what is the nth order linear non-homogeneous ODE. Its general form is what a n of x dny by dxn plus a n minus 1 of x dn minus 1 y by dxn minus 1 plus so on plus a2 of x. It's d square y by dx square or y double dash. You can write plus a1 of x dy by dx or y dash and a naught of x into y is equal to some function f of x. This was the general nth order differential equation with variable coefficients. Where these coefficients are functions of x only, where x is the independent variable and x may vary between a to b. Okay, x belongs to some interval which is a subset of real numbers. Coefficients are functions of x only. These coefficients could be constants as well. Coefficients could be constants as well. Coefficients could be constants. In that case, this differential equation is called nth order linear non-homogeneous ODE with constant coefficients. In this case, it is with variable coefficients. Now, it's general nth order. Now, if we write a first order differential equation out of this, how can we write? So only this portion of this nth order differential equation is of first order because we have first derivative, zeroth derivative, and the right hand side. Okay. I also told you that if this right hand side function is 0, then this equation will be called homogeneous ODE, nth order. Now let us write the first order differential equation by looking at that nth order differential equation. First order ODEs. As I told you, we can write first order ODE in this form, general. Okay, a naught of x y is equal to some function small f of x. Write it in this form. We call it equation 1. Okay. Now, if this differential equation it has different forms, in fact. This is the more general form of the first order differential equation. We can divide this differential equation with this coefficient of dy by dx. If we divide this, provided that if you can say that a1 of x is not zero, then dividing this equation on both sides by a1 of x, we get a1 of x. Okay. Y is equal to f of x divided by a1 of x. Okay. Now, if we call this coefficient of y as a p of x, where it is a naught of x divided by a1 of x, and q of x, the right hand side function, f of x divided by a1 of x, then this equation can be written as dy by dx plus p of x, y is equal to q of x. Okay. This is basically called general form of first order ODE. This is called standard form. Of ODE. Okay. Now, there is another form of first order differential equation. If we can have this form as well. Maybe let me, sorry. We can have another form dy by dx is equal to, it could be a function, maybe you can write h of x into g of y. Okay. And another form we can separate, or another form could be h of x dx plus or minus g of y dy is equal to 0. Okay, if you simplify this and you take this thing on the other side, you can get again this form. Okay, you separated the variables here, or g of y, or more generally, you can say that more generally, the equation could be of this form: h of x, h1 of x, g1 of y dx plus h2 of x, g2 of y dy is equal to 0. This is more general than this one. Okay, these three forms of the first order differential equation is a separable form. Okay, next we are going to discuss separable ODEs. Separable ODEs are those ODEs in which we can separate the variables x and y. For example, in this case, if we call it 1, and we call it 2, and we call it 3. In all these three forms, we can separate the variables. If we consider 1, from 1, we can say that we divide the g of y on the other side, and we keep this dy here, and we have h of x here. We bring the x on the other side. Now, you can see that we have separated the variables y and x. Okay. Now, this helps us to solve this differential equation. This is the first order differential equation in which we can separate the variables. Similarly, in equation 2, we can again separate the variables. You just have to take this thing on the right hand side, the variables will be separated. Similarly, in the case 3, the second could be written as this minus h of x dx. Variables have been separated in the second case. In the third case, you can take this thing on the other side and you can write it h2 of x g2 of y dy is equal to negative h1 of x g1 of y times dx. Okay. Now, in order to separate the variables, you have to divide this h2 of x here on the right hand side and g1 of y on the left hand side, provided that h2 of x and g1 of y, they are not zero. Okay, so we can write here g2 of y divided by g1 of y dy is equal to negative h1 of x divided by h2 of x dx, provided that these g1 and h2, they are not zero for all values of x, okay, in the domain. So equations of this form, this, and this, these are basically, they are called separable ODEs, as we can separate the variables. There's a question in the chat window. So how do you know what to divide by? Who's this? Mohammed Jahzeb. You have any question? You can ask me. Jahzeb, talk to me.
Sir, how do you know what to divide by in, for example, case 3 for separable ODEs?
You have to separate the variables. You have to take y on the left hand side and x on the right hand side. So you have to judge yourself. How can we separate the variables? So you take dx, dy, either of these two you take on the other side and then try to separate them. Okay, you can see here that this is a function of x, this is a function of y. So the function of y should stay here with dy. We divide h2 on the other side. Similarly here, you have dx, okay? And then h1 of x should stay with dx. You have to divide by g1 of y on the left-hand side in order to separate the variables. Okay?
Thank you, sir.
You have to keep dx and dy first separate, and then accordingly you divide those functions accordingly. I hope you get it. If you have any questions, easy. Yes.
Does it mean that equation 2 and 3 both are separable ODEs?
Yes.
Equation 1 is not separable.
Equation 1 is also separable. In equation, in first case, you have two functions, h of x and g of y. They are multiplying here with each other, but we can separate them. Yahan se you can take this dx on this right hand side and then you divide g of y here on the left hand side. The variables will be separated. Let me give you examples of these things. Board change. Let me change the board. Maybe it's not working. Okay, let me clean the board. Example 1 for the case 1. If you have dy by dx is equal to maybe 2x e to the power x plus y. Okay. Then can you separate the variables here? You can write here 2x e to the power x and then e to the power y. You can separate this thing. Okay. Now this is your first function, h of x, and this is your g of y. Okay. Now here you have dy by dx. Now you take this dx on the right hand side, dy remains here, and g of y, you divide it on the left hand side. Okay. 1 over e raised power y, and then you have 2x e raised power x into dx. Now we have separated the variables. Do you have any y here? No. Do you have any x here? No. So we have separated the variables here. So we get this thing. Now, once the variables have been separated, you can integrate on both sides. Okay. Once the variables have been separated, you can integrate on both sides. Now, in order to solve differential equations, your integration techniques should be very strong. Otherwise, you can stuck in the integrations. Now, integrating both sides, on both sides, with respect to x or with respect to y. No. Now, this side you have dy, so you have to integrate this thing with respect to y. And on this side, you have dx. So you have to integrate this right with respect to x. Okay. So we write here e raised power negative y dy is equal to 2x e raised power x dx. Okay. Now, when you perform integration, you add a constant of integration here. Okay. The moment you apply integration on both sides, you have to add a constant of integration. Okay. So now you have to integrate here. You get e raised power minus y over minus 1, and here you have to apply integration by parts. You can choose this function as the second function, integral function, and this one as a derivative function. So x e raised power x integral e raised power x negative integral 1 into e raised power x dx plus c. So this is done by integration by parts. I hope you know what is integration by parts. Now this can be written as 2x e raised power x negative 2 यहाँ पे भी multiply होगा e raised power x का integral e raised power x ही होगा. So you get e raised power x plus c. Here you get negative e raised power negative y. So you get 2x minus 2 e raised power x plus c and e raised power negative y. So this is your solution of the given differential equation. Okay, we had to solve this ODE. So this is your solution. You can further simplify this solution. How can we do that? Can we write an explicit function y in terms of x?
So by taking log sides.
Yes, we can take log, but here we have negative. We have to take this negative first on the right hand side. We multiply it on the other side, and then we can take log. So this can be written as 2x minus 1, or you can write here 1 minus x e raised power x plus c. Now, by taking natural log on both sides, this gives us natural log of 1 minus x e raised power x plus c. Okay. Now you can multiply this negative here on the right hand side, and then you can take this negative 1 on the top of here in the power of this function. Then you can take its reciprocal. So there are further simplification is possible. But you just put it here, positive and negative here. Now this is your solution. This is an explicit function y in terms of x. I hope you know what is explicit function and what is implicit function. So if you stop it here, this is your implicit solution of the given differential equation. And this one is the explicit solution of the differential equation. Okay. Implicit solution. And this is your explicit solution. A solution of a differential equation which in which y cannot be written as a function of x explicitly, that is called implicit solution. Okay, and if we are able to simplify this solution by using some algebra or some mathematical rules, if we can write y in terms of x only, then this kind of solution is called explicit solution. Okay, I hope you get it. If you have any question, you can ask me. So this was the case one. No questions? Okay. Then we are going toward the second case. Is very obvious. Well, I hope you can do it. Let's discuss the third case. Another case is also possible, fourth case. Let me first discuss the third case and then we'll discuss another fourth case. Let me find some examples for you. Case 4. Yes, here. Example 2. We need to solve the following ODE. Okay. The ODE is given by e raised power to y minus y times cosine of x dy by dx is equal to e raised power y sine of 2x. Okay. It's a kind of similar case 3. If you multiply this dx on the right hand side and then you bring it on the left hand side, you'll get the case 3. Okay, so you can see here that we can bring this dx on the right hand side and we can write 2y minus y cosine of x dy is equal to e raised power y sine of 2x dx. Okay, once we have separated dy and dx, then we see accordingly which function go where. So this is your y function of y. This is function of x. This will stay with dx. This will go on the other side. Now here you have function of y. It should stay with dy, and this function cosine of x, it should go on the right hand side. So this is how we can separate the variables. So e raised to 2y minus y, it will stay along with dy, and ey comes down here. E raised power y dy is equal to sine 2x stay here, and this cosine of x comes here in the denominator on the right hand side. Now we can simplify this thing further before applying the integrations. So we can separate this one and simplify. This becomes power y minus y e raised power minus y. We separated this. So this becomes dy is equal to sine 2x is what? You can use trigonometric. Yes,
Cos
it is 2 sine x cos x. So cos x cancelled, we get sine 2 sine x dx. So, but remember here that cosine of x should not be 0. Okay, for all values of x. Otherwise, we cannot divide this thing with cosine of x.
Sir, would the range be given?
Range. We don't, we are not normally given the range of the differential equation. We are given the domain of X.
Yes,
Okay.
sorry.
So X could be here between 0 and 1, or it could be A and B, but still we are not talking about the domain of the differential equation or domain of variable X. Okay, in the next lecture, maybe after a couple of lectures, we'll discuss existence of unique solutions of differential equations. Okay, and then we'll discuss interval of solutions, these things, and after that, we'll take into account the domain of the differential equation and the domain of the X, all possible values of X, how to handle them. Okay, but still we are trying to learn how to solve these differential equations. Okay. Later on, we'll talk about the intervals of solutions and domain of the variables and these things. So we got this thing. On the left-hand side, we have only y. On the right-hand side, we have only x. Now, what we need to do here, we just have to apply the integration. Okay. So then integrating both sides, what do we get here? E raised power y minus y e raised power negative y dy is equal to 2 integral of sine x dx, okay, plus a constant of integration. Okay. Now, I hope you can do these integrations and you can get the solution. I hope you can do it. Anyone who cannot do it? So that's good that everyone can do it. So after performing, here you have direct integral, here you have integration by parts. Integral of sine is minus 12. Okay. And then simplifying, you can get your solution. Either it would be implicit solution or explicit. Okay. Now another possibility where we started here. Now you can see that this thing, this equation or this equation, it is not separable. Okay. This equation is not separable. You cannot separate the variables x and y. For example, if I write here example dy by dx plus 2y is equal to 3. Can we separate it?
Yes, sir.
If I write here this thing, now can we separate it? If we have a constant here, then we can separate. Okay. If we have constant here, then we can take this thing on the right hand side. So we can write here dy by dx is equal to 3 minus 2y. And then this whole thing comes down on the left hand side. 1 over 3 minus 2y dy is equal to 1 dx. Okay, now in this case, we can separate them. Okay, if we have a constant here, constant or 0, even if we have 0 here on the right hand side, we can still separate the variables. But if we have a variable here, variable means function of x, then it would not be possible to separate the variables in this equation. I hope you get it. Let me explain this with the help of example. Now, if we have dy by dx plus maybe 3xy is equal to e raised power x. Now, can we separate the variables here? No. If we take this thing on the other side, we have a mix of variables x and y. We cannot separate the variables. Okay, so this is not separable, or you can say non-separable ODE. Then what we call this kind of differential equation? It is called linear ODE. Linear ODE. So in general, this ODE is linear first order differential equation. Okay, this is called linear first order ODE. Okay, this is called,
If
yes,
like the variables can't separate, then it's linear.
in only in this case. If we have dy by dx plus p of x by q of x, we might have a function. Like in general, this is the standard form of first order differential equation. There was a general form of the first order differential equation, and it was what it was a1 of x dy by dx plus a naught of x dy is equal to some function f of x. Yes, this is called linear first order ODE. Okay, because it is, we have derived this equation from the nth order linear non-homogeneous ODE. So it's nth, that was nth order, and this is first order. First order or linear, these two things are same. So this is again linear first order differential equation. This is again first order linear differential equation, but it is not separable. Then we call it linear. If it is separable, in case we have a constant here on the right hand side, or we have a zero on the right hand side, then it is linear as well as separable. Okay, an equation can be both. It can be both separable as well as linear. Okay, so this equation is both separable as well as linear first order differential equation. But linear equation, linear first order differential equation, is not always separable. You have to look at the type of equation in order to basically see whether the given differential equation is separable or not, whether it is a linear, whether it is a separable. Now, if the equation is separable, then we can separate the variables, and then we can apply integration on both sides, and we can get the solution of that differential equation. But if the equation is linear, we cannot solve that equation. We cannot solve this equation by separating the variables. So we need to find some other way to solve this differential equation. Okay, we need to find some other way to solve this differential equation. Till now, if you have any question, you can ask me. Someone has raised the hand, Zoha Khan. Ji Zoha, talk to me.
Sir, ये linear से मैं थोड़ा सा convinced नहीं हूँ कि when we see at this equation हम e of x देख रहे हैं, हम 3xy देख रहे हैं, तो इसको ये linear form में कैसे, मतलब linear is basically straight line, तो क्या करता है और e of x करेंगे
linear in the algebraic equation is something different, and linear in the differential equation is something different. Okay, linear means that in each term dependent variable is linear, means here we have one, here we have one. Okay, we discussed linear and non-linear equations in the previous lecture. What do we mean by linear differential equation? It is different from the linear equation of a line. Okay, if you have an algebraic linear equation, its graph is a straight line, but linear differential equation is a different thing. It is not same as like the linear equations. Okay, linear differential equation, अगर आपको confusion है linear and non-linear differential equation में, then you can see my previous lecture. I explained what are linear differential equations and what are non-linear differential equations. Okay, linear differential equations are basically they are comparatively, there are methods to solve linear differential equations, as well as non-linear differential equation for the first order. Okay, if we have a first order differential equation, whether it is linear or non-linear, there are methods to solve them. But when we move towards the second order differential equations, in case of non-linear differential equations of second order, it is very hard to solve them. Okay, there are very rare methods, analytical methods, which can give us solutions to non-linear differential equations of second and higher order. In that case, we solve them by using some series kind of solutions. Okay, series solutions of those differential equations, or we use numerical methods to solve non-linear differential equations, which are of order 2 and higher. Okay, you can see here that in case of separable differential equations, we have solved this differential equation. Now this is what? This is non-linear differential equation. Why? Because we have an exponential function in the dependent variable. If we have an exponential function in the dependent variable, then this equation is non-linear, obviously. Okay, linear and non-linear first order differential equations, we can solve them by using separable or some other techniques. We'll discuss more in the upcoming lectures. First order non-linear differential equations are easy to handle, but when we have second order non-linear differential equations, then they are very difficult to handle. There are very few equations whose solutions are possible. Okay. Otherwise, we have to find some other ways, series kind of solutions, in order to find solutions of those non-linear differential equations, or we have to use numerical methods. Numerical methods are entirely different from these kind of methods. These methods are called basically analytical methods to solve differential equations. Analytical methods means we use integration and different techniques of calculus to solve the differential equations. Okay. I hope you get it, Zoha. Do you have any other confusion?
No, sir. Thank you. सब समझ आ गया.
Okay. Now let's discuss linear first order differential equation, how to solve them. Now, either we have this differential equation, we can convert always this differential equation into this form by dividing the coefficient of dy by dx throughout the equation, okay, on both sides. Whenever you have this kind of differential equation, linear first order differential equation, you always have to convert this equation into this form, into standard form, then we can solve it. Okay, in this form we cannot solve it. Okay, first you have to convert this equation into this form, which is the standard form of the linear first order differential equation, and then we'll try to solve it. Now let us discuss how to solve it. Later on we'll solve this equation, okay, or the similar kind of. Now, to solve linear first order ODE, it's this thing, this one, okay. If we call it equation 1, if we call it equation 1, and we call this equation 2, okay. The first step is what? Step 1 is convert the given linear first order ODE in general form. if it is in general form. Convert the given linear first order ODE into standard form. Okay, standard form, just like the equation 2. Okay, once you have this equation, dy by dx plus p of x, y is equal to some q of x. Okay, if you have this equation, then now in the separable differential equation, we separated the variables and then we applied the integration. Okay, to reverse that derivative which was involved, first order derivative, we had to reverse that derivative in order to get the original function. Okay, now sorry, in order to find the solution y of x, because I told you in the previous lecture that we have to find this solution. Solution is what? This y. Y is what? Is a function. Y is a function of x. Okay, our target is to find y. So y can only be calculated, or y can only be reversed here. The derivative can only be reversed here if we apply integration here. But if we apply integration here, then integral and the derivative, they'll be messed up. We cannot reverse the derivative by simply applying the integration on both sides, because here we would have integral on p of x into y. So what kind of integration we do here in order to apply the integration, either we apply integration with respect to x or y, because there is a mixture of variables x and y. So what we do here, we have to combine these two terms. Okay, and we have to bring this term within the derivative term. How do we do this thing? I hope you don't understand this. Let me explain. We try to find some function. We try to find some function. If we multiply the left-hand side with that function, it becomes feasible for us to integrate, and then we try to cancel out the derivative and integral. Okay, now there is a standard form of that function. If we multiply this equation 2, multiply equation 2 by e raised power integral p of x dx. Okay, this is a standard function and it is called integrating factor. In short, we write it IF, and it is called integrating factor. Okay, integrating factor. Now, if we multiply generally this equation with this function e raised power integral p of x dx on both sides. Now I'm going to multiply this equation with this thing times dy by dx, plus when we multiply this with the left hand side, it will be multiplied with both the terms. So here we'll have e raised power integral p of x dx times p of x y is equal to what was the function? Q of x. Q of x times e to the power integral p of x dx. Okay. Now, look at the left-hand side of this differential equation now. Look at the left-hand side of this differential equation. What it becomes.
So the product rule, right?
Can you repeat?
So the product rule.
Product
for
rule. It's a product rule now. Product rule of what? Again, now the left-hand side, if we write this left-hand side in this form, dy by dx of y e to the power integral p of x dx. And the right-hand side remains same, q of x e to the power integral p of x dx. Okay. Now, the left-hand side of that equation has become now the product rule of this whole derivative. If you open up this thing, you get the left-hand side here. How? You apply the derivative on the first function, it becomes dy by dx, second function remains as it is. Plus y as it is, derivative of this thing. Now, if you apply the derivative of this thing, what do you obtain here? Exponential of f of x. What is the derivative of exponential of some function? It is, let me write it here. Derivative of e to the power some function of x. It is what? It is e to the power f of x times f dash of x. Okay. I hope you have seen this differentiation in calculus 1. Now, if you have e to the power integral of p of x dx, then the derivative of this thing is what? It is e to the power integral of p of x dx, and then the derivative of this power function, which is what? It is integral p of x dx. When we take the derivative of this thing, integral and derivatives will be cancelled out and we'll get only p of x, which is, here we have p of x. Okay. And y remains same. So the left-hand side will always become a product of y and this integrating factor. Okay, integrating factor function. The left-hand side of that linear equation, this one, it will always become a derivative of product of these two functions. Okay. Now, if we apply integration on both sides, then we can eliminate the derivative. Okay. After obtaining this form, now you can apply the integral on both sides. Integration with respect to x on both sides.
सर
जी
सर आपने यहाँ पे एक टर्म मिस नहीं कर दी?
कौन सी?
आपने ये dy by dx लिख के अंदर ये y और e और ये इंटीग्रल फैक्टर तो लिख दिया है, लेकिन प्लस आपने इंटीग्रल फैक्टर इनटू p of x y नहीं लिखा हुआ इस वाले इक्वेशन में.
Do you know the product rule of differentiation?
Yes, ठीक है.
We apply the derivative first on this first function. The second function remains as it is. We obtain this first term. Okay. And then we apply the derivative plus. We apply the derivative on the second function. The first function remains as it is. We get the second term here. This is what I was explaining before. I hope you get it. If you have any confusion, still, I can take this derivative if you want. You got it? The only thing which is some technical here, the derivative of this thing, the derivative of e to the power integral p of x dx. It is what? It is e to the power integral p of x dx times the derivative of the power function, which is integral p of x dx. Okay. Now the derivative integral cancel out each other. We get only p of x here. Okay. This gives us only p of x. Okay. So y as it is, the derivative of the second function is what? It is e raised power p of x dx times p of x. So this was I was talking about. So the one term will definitely be eliminated. I told you in the start of solving this differential equation that we have to reverse the derivative. Okay, if we have two terms here, we cannot reverse the derivative easily. We have to combine these two terms on the left hand side into a one term, and the derivative should be outside. Then we can take the integral. Now, by taking integral on both sides, you can see that what do we have? E raised power integral p of x dx. Okay, integral respect to x, integration respect to x. Here we have integral again q of x e raised power integral p of x dx. This whole thing respect to x. Okay, plus the constant of integration. Now, this term involves only x. We can integrate it by using some integration techniques. But here in this term, we have a derivative and integral. This derivative and integral, they are cancelled with each other. And what do we obtain here? We obtain y integral, sorry, e raised power p of x dx is equal to integral of q of x e raised power integral of p of x dx, and then whole dx. Okay. Now, what we wanted to compute y. Okay. You can take this thing on the right hand side. So we obtain y of x equal to this will be divided here in the denominator, and then we can take it into the numerator. It becomes e raised power negative p of x dx times integral of what? Q of x into e raised power integral of p of x dx whole d of x plus यहाँ पे c भी था प्लस c. जब आपने इसको डिवाइड किया तो ये c के साथ भी डिवाइड होगा यहाँ पे भी. So it becomes c, या आप इसको ब्रैकेट में लिखते हैं यहाँ पे. ठीक है. This term will be multiplied with this plus c both. Okay. So this is your solution. This is your explicit solution. Now you can use the whole procedure for solving linear first order ODEs, or you can just use this formula for solving first order ODEs. Okay, linear first order ODE. If you have any questions regarding this procedure, you can ask me. Otherwise, I'm going to show you a couple of examples of linear first order ODE. Okay. Now let's try to solve a couple of examples using this technique. Examples. One, maybe. Let us we have dy by dx plus 3y is equal to maybe 1. Okay. It's a linear first order differential equation with constant coefficient. It is separable as well. So the first example I'm giving you, linear equation, which is separable as well, so that you can solve this equation by using two techniques, by separating the variables and then using the method which we have discussed for the linear first order ODEs. Now, I hope you can do it yourself by separating the variables. I'm going to show you only the solution of linear first order ODEs. So in order to solve, this is a linear first order ODE, we first need to calculate integrating factor, which is e raised power integral p of x dx. Now, what is p of x here? The coefficient of this term should be 1. Then this, the coefficient of y is what? It is your p of x, okay? And the right hand side is your q of x. In case we have a kind of this differential equation, maybe 2 dy by dx plus 6y is equal to 2. Then first we have, this is a general form, okay? General form of first order linear ODE. First we have to convert it into standard form by dividing the coefficient of dy by dx on both sides of this equation, okay? First we have to convert it dy by dx plus 6 by 2 is 3y and 2 by 2 is 1. We obtain this equation, okay? If the linear first order ODE is not in the standard form, first you have to convert it into standard form, okay? Then you would see what is your p of x, okay? P of x is the coefficient of y. Now here it is e raised power integral 3x, 3 dx, which is e raised power 3. 3 comes outside, integral of 1 is x. So it becomes 3x. Okay. You don't add a constant here. Okay. You don't have to add a constant here. Why? Because the constant in the exponential function, integration is in exponential function. It doesn't change anything. Okay. You don't add it here. Either you add it or not, it doesn't change your solution. So normally we do not add integration constant here in the integration factor, integrating factor. So once you obtain your integrating factor, G.
I'm sure अगर हम डालेंगे तो वैल्यू तो चेंज हो जाएगी क्योंकि let's say e to the power c एक और साथ मल्टीप्लाई हो रहा है
यहाँ पे प्लस c आ जाएगा, ठीक है? It becomes e raised power 3x into e raised power c. E raised power c is another constant. It becomes c naught e raised power 3x. Okay?
Yes sir.
अब आपके पास c naught आया ना जब यहाँ पे,
जी सर.
अब आप इसको दोनों साइड्स पे मल्टीप्लाई जब करेंगे तो दोनों साइड पे c naught आएगा ना,
सही कह रहे हैं सर.
वो दोबारा कैंसिल हो जाएगा.
सही हो गया.
Does it change anything?
No sir.
No. किसी का माइक ऑन है, काइंडली म्यूट योर माइक. Okay, I hope you get it. It doesn't change anything. Either you add the constant of integration or you do not add that constant. Okay, so we don't add it here because it doesn't change anything. Now we multiply, once you get the integrating factor, you multiply this equation with the integrating factor. You don't need to multiply it, you can directly write what you can directly write that this equation, आप यहाँ पे just लिख दें, multiplying equation 1, maybe we call it 1, equation 1 by integrating factor, we obtain, okay? We obtain, what do we obtain? We obtain dy by dx, y times integrating factor is equal to right hand side times integrating factor, okay? We multiply integrating factor on both sides. Now integrating this back to x, now integrating with respect to x on both sides. Okay. Now, if you integrate it here with respect to x, you integrate it here with respect to x. So this derivative and integral will be cancelled out. And what do we obtain here? We obtain y is equal to, sorry, y times e raised power 3x is equal to integral of 1 into 3 power x. 1 to kuch bhi nahi hai. We have e raised power 3x plus c. Okay. Integral of e raised power 3x will be e raised power 3x divided by 3 plus c. Okay. Now you divide this e raised power 3x here. When you divide it here, e raised power 3x, e raised power 3x cancel. What do you get? 1 by 3 plus c into e raised power minus 3x. Okay. So what do you get here? You get y of x is equal to 1 by 3 plus c e raised power negative 3x. So this is your explicit solution of the given differential equation. Okay, I hope you get it. If you have any question, you can ask. Let's try a couple of more examples and then we'll move to the next topic. Let's do this one. If you have any question in this example, you can ask me. If you don't have any question, then let me write another example for you. This will be relatively difficult. Maybe this one. Solve the following ODE, maybe x square minus 9 y dash plus x y is equal to 0. Now, this is not in the standard form, it is in the general form. First, we have to convert it into standard form by dividing with this factor. So what do you obtain here? Y dash plus x over x squared minus 9y is equal to 0. But you have to be very careful. You look at this coefficient x squared minus 1, x squared minus 9. When you divide this equation throughout with x squared minus 9, then this factor could be 0. Okay, this factor could be 0. So you have to mention here that x squared minus 9 should not be equal to 0, means x squared should not be equal to 9, means x should not be equal to plus minus 3. Okay. So if we are given that the domain of x means x belongs to R, then x cannot be plus minus 3 in this case. Then you have to mention here that either x is not equal to plus minus 3, or you can say that for all x belongs to what? It is negative infinity to negative 3 union negative 3, 3 union 3 to infinity. Okay, so you have split this R into 3 intervals, and you have to eliminate minus 3 and 3 from this real line, because it is not possible to bring this factor in the denominator. Okay, so you have to tell this thing that x is not equal to plus minus 3. Now you can solve this thing by using the technique which we have discussed earlier. What is your p of x? This is your p of x. Okay, then integrating factor should be what? Sorry, e raised power integral x over x square minus 9 dx. Okay, now how can we integrate this thing? It can be you multiply here 2, you divide here 2. Okay, now you have derivative of the denominator in the numerator. So it can be 1 by 2 natural log of x square minus 9. Okay. Okay. You take normally an absolute value here, because log is never negative. So now this scale 1 by 2, you can take it on the power by using the log property. So it becomes x square minus 9 whole power 1 by 2. Now e log this will be cancelled, and what will be your integrating factor? It will be x square minus 9 whole raised power 1 by 2. Now you can see here that you have x square minus 9 square root. What does it mean? It means that x is not possible within this interval. It is not possible. Why? X cannot belong to this interval. Why? Hello? Yes?
Negative value here.
Huh. Because if we put any number from this interval here, it will give us a negative number, and the square root of the negative number is not possible. Okay. You further mention here that x belongs to what? Negative infinity to negative 3 union 3 to infinity. Okay.
I'm sorry.
जी जी.
हम complex numbers को avoid क्यों कर रहे हैं?
Because we are discussing the real solutions of ODEs, maybe.
ठीक है.
We are
ठीक है,
not
sir.
going towards the complex kind of solutions. Okay.
ठीक है, sir.
Okay. So you have to exclude this interval as well. You have to mention here that x belongs to these two intervals, union of these two intervals. Okay. Now, once you get your integrating factor, then you multiply the original equation, this one in the standard form. Okay. This equation with the integrating factor, and then you after multiplying this equation with the integrating factor, what do you obtain? You obtain dy by dx, so times y into integrating factor is what? Square root of x square minus 9 is equal to, you have right inside 0, so you get 0 here. Okay. Now integrating both sides, what do we get? Y into square root of x square plus 9, sorry, negative 9. Negative 9 is equal to constant, integral of 0 is constant. Okay. Now you just divide this thing on the right hand side and you get your solution, x square minus 9. So this is your explicit solution, but remember that if x belongs to what? It belongs to negative infinity to negative 3, union 3 to infinity. Okay?
सर मुझे एक चीज समझ नहीं आई
जी जी
सर जब आपने इंटीग्रेटिंग फैक्टर लेफ्ट साइड में नीचे लिखा हुआ है ई पावर नेचुरल लॉग ऑफ एक्स स्क्वायर माइनस 9 और ऊपर अंडर रूट है ये आगे एक्स स्क्वायर माइनस 9 किस तरह हुआ है?
I used a log property of exponential log. If you have e and log, okay, of some function, then e and log, they will be cancelled. Why? If you take log on both sides, ठीक है, तो आपके पास क्या आ जाएगा? ये आपके पास नीचे आएगा, ठीक है? Let me, ये आपने O levels में पढ़ी होगी ये प्रॉपर्टी.
इससे समझ गया हूँ याद आ गया ठीक
Let me repeat it if you don't understand it. Thinking, if we write it y is equal to e raised power log of f of x or x something, whatever you have here, x. You take log on both sides. Log y is equal to what? You take log of e raised power log of x. Okay. Now, with the property of log, you take this thing down here. Natural log of x into natural log of e. Natural log of e is 1. So you have log of y is equal to log of x. So it means y is equal to x. Okay. So e and log, here we have y is equal to e raised power log x. Okay. After taking log on both sides, where do we have arrived here? Y is equal to directly is equal to x. What does it mean? E and log, they cancel with each other. And x, yeah, x comes here. Y is equal to x. So we have used here the property of e logarithm. It's e power log of this thing, e log cancelled out, and we get this thing.
So why do we remove the mod?
Until we have log here, we needed this mod because
Yes, sir.
log of negative numbers is not possible. Okay. And whenever we have here, we have a square root here. Okay. Then we look at it according to the square root functions. Okay. In order to get the real values. We don't want to go into the complex values. Okay. Here,
Sir, if we had left the mod in, तो हमें domain तो छेड़ना नहीं पड़ेगा, because then it'll just be all real solutions.
if we have
Sir, अगर हमने mod, if the mod was left in, like if we didn't remove the mod, then we wouldn't have had to change the domain, because the square root of the mod is always going to be real.
Yes. So right, but we look at the simplifications by looking at the functions. Okay. You don't need to put a mod here. You just have to, again, you don't have mod here anywhere. Okay, you can just put a bracket here, but you have to take care that this this factor should not be negative. And in order to apply the log, this inner factor should be positive. That's why I have excluded this factor from the domain. Okay, but it depends on the situation. Okay,
Yes, it makes sense. Okay, the mod is always just with the log, not.
Okay. While you are doing some practical problems, we'll do modeling of using differential equations. It depends on your problem. What are you trying to solve? Your practical problem. Okay. What are the requirements? अभी तक तो you are doing mathematics just for calculations. You are learning calculations, how to solve, how to handle these equations. Okay, you are doing maths, simple maths. Okay, which you think the mathematics is dry. But whenever you apply mathematics on real things, then you have to take care of your physical phenomena, your practical problem. उसको आपने देखना होता है कि कैसे हम इसको आगे लेके चलेंगे. ठीक है? You don't do just calculations for nothing. So these things are basically, we are trying to prepare you so that whenever you have a practical problem, then you can handle that problem. Okay? I hope you get it. अब यहाँ पे mod लगाना है नहीं लगाना, यहाँ पे square root है, domain को निकालना है नहीं निकालना. Well, it depends on your situation as well. If you are doing some a problem in which the complex numbers are allowed, then you don't have to exclude this interval. You have to work with this interval as well. Okay? So it depends on that thing. Now you get this solution, and the solution, all possible values of x, they belongs to this interval. Okay. Now from here we have seen one thing, that if for a differential equation the domain is given x belongs to R, for all x belongs to R, okay, then this differential equation is defined for all values of x belongs to R, because it will never give you an undefined thing. यहाँ पे अगर आप 3 पुट भी कर दें तो ये फैक्टर 0 हो जाएगा. You get xy is equal to 0, which has no meaning, because it gives you y is equal to 0, because x you divide it here on the right hand side, then you get y is equal to 0. You get the trivial solution. So this equation has a trivial solution. Right? If you put y is equal to 0, this equation is satisfied. Okay, but we are not interested in trivial solutions in practical situations. We are interested in non-trivial solutions which are not 0. So this equation is defined for all values of x. No value of x can make this equation undefined. Equation is defined for all values of x, but the solution is not defined for all values of x. Solution is defined only for these values of x. So it is possible that differential equation is defined for different values of x, and the solution of that same differential equation is defined for some other values of x. Okay. So this is usually the subset of this thing. Okay. The domain of this is domain of the differential equation. Means this differential equation is defined for all values of x. This is the domain of the differential equation. This is the domain of this differential equation. But after solving, we get this solution. Now, the domain of the solution is something different. Okay, so it is possible that the differential equation is defined on the different domain and the solution is defined on the different domain. Okay, I hope you get it. If you have any question, you can ask me.
Is it necessary for the domain of the solution to be a subset of the domain of the differential equation?
It is. It may be subset. It may be equal to that set as well.
Can it be bigger?
Oh, normally it is not bigger. I don't think so. It's not.
But do we have a fixed constraint? Is it like proved somewhere, or it's just an idea?
It's just an observation. We don't have any proof of this thing.
Okay, sir. Thank you.
It may be larger than that set, and that set may be larger than this set as well. Okay, it depends on the differential equation. Yeah.
सर ये जो आपने डेरिवेटिव लिया y to square root x square minus 9 ये कैसे लिया?
कहाँ पे? ये वाला? हाँ?
Yes sir.
This one?
y की टर्म को
यहाँ पे देखिए, we have this equation standard form. इंटीग्रेटिंग फैक्टर हमने कैलकुलेट किया, तो इंटीग्रेटिंग फैक्टर इससे मल्टीप्लाई करेंगे तो ये दो टर्म्स जो हैं ये कंबाइन होके प्रोडक्ट रूल बन जाएंगी इस चीज का. I told you while discussing how to solve linear equations. हाँ?
इसको फार्मूले से किया जो पीछे हमने लिखा था, तो आंसर में मेरे पास 1/2 क्या है इसके अलावा, तो क्या ये आंसर ठीक होगा?
मुझे आपकी आवाज कट रही है यार. Can you repeat and speak clearly?
सर मेरी आवाज अब ठीक आ रही है?
जी बोले.
सर y of x में मेरा आंसर आ रहा है 1/2 plus c divided by square root x square minus 9. क्या मेरा आंसर ठीक है?
नहीं, ये आंसर होना चाहिए ना। 1/2 कहाँ से है आपका?
सर मैंने उस फार्मूले से किया जो आपने पहले लिखवाया था, y of x is equal to इंटीग्रेटिंग फैक्टर 1 by इंटीग्रेटिंग फैक्टर इनटू उस फार्मूले से किया।
गलत है,
Product
यही आना,
लगाया।
यही आना चाहिए।
ओके सर, ओके सर।
ठीक है, it should be the same answer. You might have done some mistake. Recheck it. जी।
वैसे अगर 1/2 वैसे हम लिख भी दें साथ, would it change anything? हमारे c की वैल्यू ऑटोमेटिकली चेंज हो जाएगी उसके बाद तो?
चेंज तो नहीं होगा, लेकिन आप एक मिस्टेक को जस्टिफाई कर रहे हैं। योर आंसर शुड बी दिस।
वो तो बिल्कुल सही कह रहे हैं आप, आंसर तो ये आना चाहिए था, लेकिन अगर गलती से 1/2
डोंट
आ
डोंट
गए।
डोंट जस्टिफाई योर मिस्टेक।
ओके
So it's just half times another constant. तो बस 1/2 a लिख दें, then just put that equal to c.
कांस्टेंट की वैल्यू डेफिनेटली चेंज हो जाएगी नहीं यार। तो कांस्टेंट की वैल्यू चेंज होगी तो योर सॉल्यूशन विल बी चेंज। सो योर सॉल्यूशन शुड बी दिस थिंग। आपकी कोई अलजेब्राइक मैनिपुलेशन में या कोई स्टेप्स में, मैथमेटिकल स्टेप्स में कोई गलती नहीं होनी चाहिए। ठीक है, यू कैन नॉट जस्ट मल्टीप्लाई अ कांस्टेंट हियर। ठीक है, आप अपनी मर्जी से कोई भी कांस्टेंट मल्टीप्लाई नहीं कर सकते। दैट मैथमेटिक्स में तो बहुत चीजें जो हैं वो एक्यूरेट सेंसिटिव होती हैं। अगर आप प्लस को नेगेटिव लिख दें कैलकुलेशंस में तो कैलकुलेशंस कहाँ से कहाँ चले जाएंगे। आपने जाना चांद पे है तो आप पहुंच सूरज पे जाएंगे। ठीक है, दिस हेल ऑफ डिफरेंस इफ यू जस्ट पुट अ नेगेटिव साइन इंस्टेड ऑफ पॉजिटिव। ठीक है, सो बी केयरफुल व्हाइल डूइंग मैथमेटिक्स। गलती की गुंजाइश नहीं होती। यू होप, आई होप यू नो इट। If you have any further question, you tell me, you ask me. Otherwise, I'm going to end this meeting. I'll upload the recording on YouTube for your convenience. Okay, then see you in the next lecture, inshallah. Take care, Allah Hafiz.